Hello, my good people. In this video, we'll take a look at what full stack development is, and I'll try to explain some of the most important concepts in a way that made sense for me when I was starting out. Don't forget to like and subscribe this video for more on full stack. Let's begin. So full stack is essentially the architecture of your app, roughly divided into two or three parts. These parts are the front end. It can go by multiple names like client and view as well. Then there is the backend or the API. The API stands for Application Programming Interface. And the backend tends to often include the database, which can be a part of its own. So in general, we have three parts. Front end, which the user sees on the computer when visiting a site, and the backend, which reacts to the user's actions and sends the data back and forth between the database and the front end. So some people like to imagine it being like a triangle shape like this, with the client, database, and API. But I found that to be a little confusing with regard to the relationship between each component. Here we have the same thing drawn a little differently. In this scenario, the different parts represent layers that the data go through. The data is not allowed to skip the API step. Why is that? Because the purpose of the API is to make sure the data is handled in the intended way. In the API, we will make doorways and logical openings for a data to pass through so it fits when coming out the other side. Imagine not having doors and you enter your house through the chimney like Santa. It works, but not very practical. The API works the same way. It follows a design pattern for distributing data, just like when we build houses for people. As far as houses go, we expect them to have doors and windows and roofs, etc. that are practical for humans. It's basically the same for designing APIs, just that it's practical for the data we use. It too needs openings that make sense. Another important point is that the frontend is generally meant to be public and exposed, while the backend is more private and can hold secrets that you don't want to display publicly. To extend on the house analogy, not everywhere in your house should be accessible to everyone. Some parts are private and some parts should probably not be used at all, like the chimney, except for Santa, of course. The mostly used design pattern, like the one I'm trying to describe here, is called REST. It stands for Representational State Transfer. For something to be considered a RESTful API, it needs to conform to a number of criteria, among them having a client-server architecture made up of a client, server, and a resource, with the requests managed through HTTP. And that matches what we've seen so far, where we have a client and it's the front end. Servers are typically the API and the resources the database. In this drawing, we can see we have the database in the center of our app and holds the state or the truth. It is surrounded by a wall with openings in it. This is the API, opening doors and windows, so to speak. Data cannot flow except through here. This is to protect our application and direct our data in a logical way so people can query it and expect it to behave in a certain way. Furthest out in the circle is the client or the front end making requests. These requests can be divided into many different types, but the most common ones are gathered in the simple acronym CRUD: create, read, update, and delete. These are the most common operations we request to the server or API to do for us. The client asks and the server answers. These operations corresponds pretty neatly to post, get, update, delete. Post requests tends to call for a creation of data, and get request just fetches the data as it is without creating something new. Update and delete basically does what it says. Let's say the client wants to show a list of users by clicking a button. Then the server calls a designated part of itself to read from the database and retrieve the specific data through a GET request so the frontend can display it to the user. But where does the logic go for manipulating the data? A common philosophy is that the frontend is lightweight with as little logic as possible, and the backend takes care of the heavy lifting. In other words, frontend is supposed to be stupid and the backend complex. This is seldom clean-cut, but as a general principle, it's a good practice. Let's go through an example of a scenario where data goes through the entire stack, meaning from frontend to API to database, back to backend, and finally back to frontend again. Let's say you visit an online store and want to purchase some new shoes. You click buy. In the instant, a post request is sent from the frontend to the backend, calling a post endpoint in the API. So what's an endpoint? Endpoints are the actual openings in the API mentioned earlier that accepts different kinds of requests depending on its intended use. So an endpoint whose purpose is to create a new customer is typically a post and expects a post request at a specific URL with the payload that contains the data for the new customer. This can, for example, be like this: post at https localhost 3000/customer with the body containing the data for the new customer. Inside the code for that endpoint in the backend is probably some logic to format the data so it fits nicely into our database tables and then write it to the database. The backend also makes sure that the user created is unique with its own unique ID, so we can track the user's information like purchase history, and that way also have the possibility of having multiple users. Maybe even have some kind of error handling if it didn't work out as well as we thought. The database handles the query from the API, checks that access is permitted with the data given, and writes to a table or a collection depending on the database. If the data gets created in the database and everything is okay, we usually like an indicator like a status code sent back so we know that it worked. This status code can be extended to the front end to direct the user to the next page after making the purchase, like a receipt page. And here you can see the entire journey from start to finish when you click buy, from front end to the back end, writing to the database, back with the status code to the back end, extended to the front end, and then the front end sends the user to another page like a receipt page, or and just displaying that the purchase was made. So to sum up, the purpose of the backend is to decouple the precious data from the front end, talk to the database, determine what the client is allowed to do, and the front end, what that is supposed to do is help the client or the user as much as possible on its journey throughout the site. And for the database, be the truth of the app over time for all users. So in conclusion, this is a very general explanation on full stack, and you can of course go much deeper into each subject presented here. Let me know what you think in the comments. I read all the comments and would love to see what you think. If you like this video, hit that like and subscribe button, and I'll see you in the next full stack video. Have a nice day.